Welcome to our Solutions for NanoAnalysis podcast, brought to you by Bruker NanoAnalytics. We look forward to bringing you a new podcast regularly. My name is Cody Morton. I'm a marketing communications specialist at Bruker NanoAnalytics and an information enthusiast. If you like to learn from specialists in their field and hear what technologies are solving their problems, you will enjoy this podcast. Every session, we will focus on a different problem that our colleagues face in the lab and in the field. Some of the solutions will be a variation of ideas you may have heard before or even worked with. We will bring you these topics in a new and interesting way and introduce you to updated and thought-provoking results. We will talk about how the problem was dealt with in the past and what we're doing to solve the problem now and perhaps even envision future solutions. Join us as we talk solutions with a variety of scientists and technicians in many different industries in the Solutions for NanoAnalysis podcast. Today we are going to talk to Dr. Marian Hamilton about studies she did while at the University of New Mexico, done in partnership with the University of New Mexico and the Kibale Chimpanzee Project in Uganda. The Kibale Chimpanzee Project is based in Kibale National Park, just east of the Rwenzori Mountains in southwestern Uganda. The park, established in 1993 and managed by the Uganda Wildlife Authority, encompasses 795 square kilometers of primarily moist evergreen and semi-didaceous forests. Kibale's rich ecosystem is highlighted by diverse populations of birds, butterflies, and mammals, including 13 primate species. Kibale is home to more than 1,200 East African chimpanzees. 5 chimpanzee communities have been fully or partially habitated to humans for research or tourism. Kibale Chimpanzee Project focuses on the Kanwari community, which comprises 50 to 60 chimpanzees ranging in the northeastern section of the park. The Ngogo Chimpanzee Project follows 2 communities located in the center of the park. A 4th community at Kananachu has been habitated for tourism, and a final group in the northern part of the park is being studied by the Sibitoli Chimpanzee Project. Thank you so much today for joining us, Dr. Marian Hamilton, Assistant Professor of Anthropology at University of Northern Colorado. Marian, I wanted to find out, how did you end up at Northern Colorado?
Yeah, so I did my graduate work just down the I-25 corridor at University of New Mexico in Albuquerque. And I finished up there in 2018 and put out an incredible number of applications to an incredible number of jobs, because we all know the academic job market is not really a fun playground to play in. But I was lucky enough to get an interview up here we are UNC, even though we are not the UNC that everyone thinks of when you hear the acronym UNC. And I came up here and I did my interview, and I immediately fell in love with the campus and the anthropology department here. We are an undergrad only anthropology department at an R2 university. So that means that we still do quite a bit of research, but there is more of an emphasis on quality of teaching and the importance of work in the classrooms than you would find at an R1, which really prioritizes the incredible importance of academic research. And while I love academic research very much, I'm also a teacher at heart. So I was really excited to find a home in a place that encouraged research, but as a means to educate undergrad students and lift up undergrad students along the way as you do it. So that's how I wound up here. And I was really excited to join a very small but mighty anthropology department here.
Awesome. I love it. And what got you interested in science as a kid? Have you always been interested in science, or did you kind of just grow into it?
I grew into it by trying to grow away from it. So both of my parents are biologists. And I was positive as a child that no matter what I was going to be, it was not going to be a biologist, because that's what mom and dad did. So there was no way that was what I was going to do. And I went through a whole slew of things from I wanted to be an elementary school teacher, and I wanted to be a veterinarian, and I wanted to be a historian, and I wanted to be a writer. And then I landed myself at an undergrad general education course at Penn State University, where I did my undergrad, that was an Introduction to Biological Anthropology, Gen Ed science course. And I fell completely and totally in love with it. And I fell in love with all of the human ancestor fossils we were looking at. And then I continued to take bioanth courses and human evolution courses. And it was what I got so excited about, waking up in the morning. That was the readings I was excited about doing. Those were the classes I was excited about going to. I took a break after undergrad and actually did teach middle school for 4 years. I taught middle school science, which sort of convincing middle schoolers that science was really awesome reinvigorated my love for science along the way. And after 4 years in the classroom, I decided I really needed to get back into the student side of things, and I needed to go back to grad school. And that's when I made that jump and ended up down in Albuquerque.
How did you end up studying primates? Did you know that that was the direction you were going to go, or did you just find some really interesting people and information?
A little bit of both. So what I really wanted to study was human evolution, and specifically human behavioral evolution. So humans are incredibly awesome, incredibly weird animals. And we are primates. We fall into the primate clade, of course. So our closest living relatives are chimpanzees. We fall in with the rest of the great apes when it comes to who we are genetically related to. And what I really wanted to study was how humans evolved as primates to do all of the super weird stuff that we do. So we cooperate, for example, believe it or not, above and beyond any other primate's ability to cooperate. So if you put, 100 human students in a lecture hall, they're probably all going to sit through the lecture and not get into a giant fist fight or throw poop at each other or, any of this. If you put 100 unrelated chimpanzees into a lecture hall, things would go very, very differently. So we have an incredible tolerance for each other and an incredible ability to hyper cooperate. And there are, any number of other weird things that humans do behaviorally. And I wanted to study how those evolved back in our past. Turns out it's really hard to study behavior in the fossil record. It doesn't stick around. It doesn't turn into stone. So one of the best ways that you can do it is through what's called the comparative method, which is observing behavior in our closest living relatives as well as other animals, and then using that in conjunction with fossil data to then build hypotheses about what kinds of environments would have led to certain behavioral traits being selected for and evolving. At University of New Mexico, we're lucky enough to have connections with Kibale National Park, which is primate park in Uganda. They've got communities of chimpanzees who live there, who are habituated with an incredible team of researchers who study them. They also have a ton of other primates who live there, baboons and black and white colobus monkeys and red colobus monkeys and all these other wonderful primates. And it was then through the connection to Kibale that I was able to get access to the primates to study, with the idea of using them as models to look back into the fossil record and try and answer questions about our human past.
That's really interesting. So what is I know that you did your doctorate thesis on this topic that we're looking at today. How did you end up talking about this specific topic? Actually, what is the topic that we're talking about with primates? And I'm looking at kind of which came first, the chicken or the egg, the topic or the information? When you're looking at what do I really focus in on? Do I look where I have the most information, or do I look where I have the most passion?
Yeah, so this was, again, sort of a multi-step process to get to what we're doing here with the XRF. So my dissertation data was actually looking at strontium isotope data, which is something that we measure using big ICP-MS machines and multi-million-dollar pieces of equipment in the lab. Because my question that I was looking at for my doctoral work was, who was moving where? Who was using the landscape in what kind of ways? Were there differences between males and females in the way that they're dispersing across the landscape? And most importantly, we know for modern primates, we know the answer is yes. The real question was, can we see that difference in the isotopic data in their teeth and in their bones? And the answer was sort of, which is kind of an answer we land on a lot in a lot of scientific pursuits that is a little disappointing, but also, here we are. Through that collection of the tooth and bone samples to then bring back to the US to collect the isotopic data on, we realized that we could learn so much more by looking at more than just this one isotopic system. We could get a ton of data on diet and a ton of data on things like trophic level by looking at concentrations of trace elements, specifically also strontium, but instead of the isotopic ratio, the actual quantity of it, how much strontium, regardless of isotopic form, is there in this particular individual or this particular species and so on. And so through that led me to looking at different forms of data collection and then using the tracer and other portable XRF units to then collect these data and then use that to try and reconstruct these things about diet, which, while not directly related to mobility, they're all tied together.
Right. You can kind of trace where a species is going in their region by what diet is available, right?
Sure. And some of the big distinctions in types of diet. So within primates, two of the big groups are frugivores, primates who eat fruit, and folivores, primates who eat leaves. And generally speaking, frugivorous species who eat fruit travel much greater distances, have much greater home ranges because they've got to travel to all these different fruit trees and get to the specific trees that have the fruit they want to eat, versus folivores who are eating leaves, who generally have much more food abundantly available in smaller areas. So they move much smaller distances. Their home ranges tend to be much smaller. So there's absolutely a driving force in how far you are moving over the course of a day or your lifetime based on what you're eating in these broad kind of categorical groups.
Now, you said that you worked with the group in Uganda. Did you get to travel to Uganda and stay there and do some studies with them?
I did. I went 4 summers to Uganda and lived at the field station there at Kabale National Park, which is part of Makerere University, is the university there in Uganda that sort of helps run a lot of it and sponsor quite a bit of it. So I lived there for usually about 2 months at a time in the summers in between semesters in grad school to collect the dissertation data that I needed.
And then did they have a lot of this data that they were already collecting, or were you adding on to the work that they were doing separately?
Yeah, so what they had that was absolutely incredible, this team has been working at Kabale for well over 40 years now. I believe we're probably pushing on 50, and I should have that date in my head, and I don't. We can add that in later. But they've been working here for an incredibly long time, and it's a collaboration between researchers primarily at Harvard and then at UNM, as well as other US institutions, and then Ugandan researchers at Makerere and elsewhere. And they do an incredible amount of work there, safeguarding a lot of the groups of chimpanzees who live in the park, anti-poaching measures, and other really important conservation work, as well as being a base station for a lot of really amazing research about what's going on in this tropical forest. And one of the things that they have done is, over the course of their 50 years working in this area, they have collected animal remains as they find them opportunistically in the forest. And they bring them back to this station, they bury them to let them decompose, they catalog the species if they knew it, they catalog exactly where the specimen was found, they have collections of things like hair and all sorts of other remains that they were able to collect and catalog. And that then formed the basis of my doctoral data, the dissertation data. And I sort of thought of it as a mock fossil assemblage in many ways. You know, these are species who are alive today whom we know quite a bit about, but these incredible collections mean that we can ask questions about, okay, if this was a fossil assemblage, and we didn't know that female chimpanzees leave their group while male chimpanzees stay, could we collect data from the bones themselves that would tell us that information accurately? Because if we can, then we can use those same methods on fossil species for whom we really don't know the answer yet.
And then were you able to determine, yes, you could make that extrapolation out?
With quite a bit of caveats, yes. If you have got really good baseline information about the environment that you're working in, which you can gather through any number of ways, there are methods that you can use to analyze the isotopic data, this is strontium isotope data, that comes back to make pretty good predictions about whether or not there is one sex that disperses while the other stays or not. So yes, it looked pretty good.
Then when Uganda was collecting all of these animal remains and recording them, for what purpose were they doing that? It wasn't, I'm sure, just because it was there and that was what they had decided to do. I'm assuming they did it for a specific purpose of study.
Sure. There have been all sorts of wonderful studies that have come out of these remains, and you can kind of go to Google Scholar and type in, Kabale National Park, and you get just an amazing amount of work that's been done by really spectacular researchers over the years. But a lot of it was sort of an understanding that these remains as we find them in the forest, even if we don't have a specific driving question we're working on now, as a collection is invaluable to understanding the modern dynamics of this endangered ecosystem, and for any number of things that maybe they couldn't predict at the time, but they knew enough to know we might not know why these are useful, but we know that they're going to be. And just as sort of diligent scientists and diligent stewards of their land, they collected these and kept them in safe, good condition for future work.
This may not be a question you can even answer, but was there a way to approach this idea before studying isotopes was available in history? Are there antiquarians that went back and you could see records that had been kept where maybe size of tooth was studied and they were able to group different things, doing studies similar to this before the technology got good enough to do?
Yeah, so as far as the isotopic question of mobility, I am not aware of any way that we were approaching that before the use of strontium isotopes. And the original work on this dates back to the 80s, looking at strontium isotopes as a tracer of mobility across a landscape. Previous to that, I mean, in modern animals, it was a lot of really hard footwork, right? It was a lot of watching, following, observing, diligent recording of information over huge stretches of time. As far as what was going on in fossil species, there wasn't really a way to do it previous to lab techniques.
Mm-hmm. And then how did you approach the study with the handheld XRF? Because that study that gives you more different information than the isotope information.
Yeah, so we knew from previous work that strontium-calcium ratios, so the quantity of strontium relative to the quantity of calcium can give you a lot of dietary information about trophic level, about all sorts of other things. And so we thought, hey, we've got this incredible skeletal collection of these known primates, and we've got this handheld XRF. Why not collect these data and sort of see where it goes? So that was we had the question driving the data collection for the strontium isotope data. And then we had sort of availability of data collection driving the, hey, let's just see what we can find part of the second part of it. And when we collected the data, it was gorgeous. It was such exciting information. And actually some of it came from the samples we ran on the ICP-MS. We asked them to also run some elemental concentrations on a subset of those samples. And we immediately saw that strontium-calcium ratio varied quite a bit between frugivores and folivores. They were really noticeably different from one another. And we went, whoa, I didn't expect it to work that well. We got to collect more because this was such a small subsample. And so that's when we brought the handheld XRF in, because we could measure every sample in our collection. And we could measure it right there in Uganda. I mean, one of the hardest parts of my dissertation wasn't the advanced statistics. It wasn't the theoretical background. It was applying for permits to export tiny portions of ground up teeth to the lab here in America. The permitting process took a solid year, external to all of the other work I was doing. So one of the absolutely game-changing things about having the portable XRF was that we could bring it to the field and we could collect the data right there, no exporting necessary. And that was like, oh my gosh, we can just bring the USB home with the data on it. And there you go, no waiting for permits. It's amazing. And we could collect a greater quantity of data. We could sample every single specimen in the collection instead of picking and choosing, because of course, to run it through on ICP-MS costs money per sample because you have to use all of the chemicals in preparation and all of these other things, plus time to run the machine. But to collect it with the handheld was just, you could collect all of it with all the time that you had there in the day. You could collect all the samples. Time was your only limiting factor.
Yeah.
So that was what brought the handheld XRF with us.
Oh, very good. So then after you got all of your permits done and approved and got some of that information back so that you could test it on the ICP-MS, did it then just underscore what you had learned in the field with the handheld? It just gave you more robust information?
Yeah, so the order is flip-flopped. We got the data on ICP-MS and we said, oh my gosh, look at this. We have to get more of this. And that's when we got the handheld out with us the next field season.
Oh, I gotcha. Okay,
Yeah.
Thank you. I was backwards.
Yeah. I probably told the story in a convoluted way, but
no, it's very interesting. And because it was your study, I'm sure you just lived it, ate it, breathed it for the 4 years that you went back to Uganda, and you probably were just waiting for the next time to go to do some more studies. Is there anything that you didn't study that you wish you would have had more time to study?
Yeah, so there's always more, right? There's always more we wish we could do. And I'm chomping at the bit for the opportunity to go back. So for example, we generally collected the data on just one tooth for each of the skeletons that we had because of time limitations. I would be incredibly interested to look at variation within individuals and measure on multiple teeth. Sometimes we've got the entire skull and the entire mandible. We could measure each and every tooth in there and see exactly what kind of variation that we see across individuals. As far as strontium calcium ratios go, which is what I'm personally interested in, talking to colleagues who are more about nutritional ecology, there are all sorts of things that they're like, oh, but what about the amount of magnesium that they have in their teeth? And does that seem to change? Can we combine measurements of health, for example, things like caries and dental issues with anything that we see in their sort of nutritional profile? So there's a whole world of other things that we could go back and collect more about for sure.
Was there anything in your studies that changed from the start of the testing and the studies to the end? Were you surprised by anything? Did you have to change methods or something halfway through?
Yeah, so one of the most interesting things that has come out of this has been, we know from previous literature that generally speaking, fruit has less strontium in it, just because of the fractionation of how plants sort of assemble their parts, so to speak. So you see that difference in strontium calcium ratios, primarily driven by there being less strontium in fruits versus more strontium in leaves. What we found, the other thing we took these measurements on and are still in the process of taking measurements on, are dried fruit and leaf samples that we brought back for for other study questions. But now that we've sort of run them through all these other things we brought them back for, we've got some sample left. So we're collecting this trace element data in my lab at UNC right now. And what we're finding is that there is an incredible amount of variation based on the species of tree, potentially. And this is all preliminary. We don't have enough sample to say any of this for sure. But it looks like there's a lot of difference based on what species of fig tree, for example, might be the primary food of a certain primate. There is a lot of variation in the quantity of strontium, the strontium calcium ratio, and also the degree of difference between the fruit and the leaves. So some trees have their leaves way up here and their fruit way down here as far as strontium calcium ratios go. And for other species, it looks much more equal. There's not a ton of difference between strontium calcium ratios of fruit and of leaves. If those differences hold up as we build a greater sample size, that would really impact what we see in the teeth of the primates who would preferentially be eating each of those species, and then of course change the conclusions that we would come to when we see those kinds of data in modern context as well as fossil context. So there's a lot of variability that we don't have a good handle on yet, that I personally wasn't anticipating to see quite that much variability between all these things. So I'm really excited to get more data over the next year. I have a student who's working with me in this coming semester to really beef up our sample size on the fruits and leaves themselves and the trace element concentrations there. So I'm really excited to see those data roll in.
Excellent. That does sound very interesting. It would be very interesting to follow up with you in the future to see what you guys found out. And I think that the students are very lucky to have such a great starting point for something interesting to go forward with. So what else do you see studying with the handheld? Do you still have the handheld in-house that you get to use? And what will you study next?
Yeah, so we don't have a handheld in-house right now, but we have one on the way.
Good.
It should be arriving here very shortly. We hope. We're waiting in great anticipation. We're going to continue doing these fruit and leaf samples of all of these different species of trees that grow in the forest there in Cavalli. That's our primary piece of data that we're working to gather. We also are working with the museum collections, the archaeological museum collections that we have housed here at UNC, to do some toxin screenings, looking for things like lead in paint, looking for arsenic and mercury on the surfaces of items so that we can properly curate them and make sure that anyone who's using them in a study has got proper handling and proper storage for everything. So it's been incredibly, incredibly helpful and useful for that. We are also looking at this is a very preliminary study, but some archaeological coffee beans that were excavated in California from a gold rush era site, hoping to use some trace element data to help us trace back where those coffee beans were grown. So where folks during the gold rush were importing their coffee from. So that's also on the docket. The other really wonderful thing is that we're going to open this up for student-centered projects. So in the past year, we've had 2 McNair scholars design projects using the XRF. They've designed it, they've collected their own data, they've presented their findings at UNC's Research Day. Actually, both students won awards from the McNair program for the quality of their work, which we were incredibly proud of. So we've got a lot of really engaged, really brilliant students that are going to come up with things beyond my wildest imaginations that we could do with this technology. So we're really excited to see where that goes as well.
Excellent. So your takeaway with the problem of studying the leaves versus fruits with primates, did you solve the problem? Did you answer your question originally?
I think we are in process. And I think what it's done is it's given us more questions than answers. And in science, that's kind of the best thing that you can hope for. At least for me, that's the best thing you can hope for. It told us that, yes, we can detect a difference in the strontium calcium ratios of frugivores and folivores and of fruits and leaves themselves from the trees. So we've gotten that far. So our sort of baseline answer is yes. And now we get to take it off in all of these other directions.
I love it. And that's where your future studies are already going, where you're going to be studying some of those fruits and leaves and the makeup of them so that you know what your information is giving you. Exactly. I love it. Thank you, Dr. Marian Hamilton, for joining us today and sharing about your fascinating research. We look forward to talking to you again in the future about other studies being done in your lab. But I did ask you at the very first, I was going to give you the controversial question for an anthropologist. Which is a better pet, cats or dogs?
So, full bias disclosure, I have both cats and dogs, and they are all very aware that I'm a dog person. I love my kitty, but I'm a dog person. However, anthropologically, they really come up as a very close tie. So cats kind of domesticated us. And there is so much cool data out there about how humans and cats became a coexisting species. And cats kind of chose to opt in with humans. Dogs kind of did the same thing, opting in with humans on the outskirts of our encampments, eating the trash that we accumulated. And both cats and dogs really performed incredibly valuable services for early humans. Cats keeping pests away, which kept disease levels down. Dogs helping with hunts and also keeping pests away and keeping disease levels down. And then we have, as a species, globbed onto dogs and said, dogs are our best friend, and have then taken the notion of natural selection in a totally artificial way, not bad artificial, but artificial nonetheless, and selected for all of the traits we see across all the dog breeds that we see today. So I think when it comes to humans, humans are a dog species, but cats are pretty great to have around too.
I love it. I love it. Thank you. I didn't know that you were going to have such a learned answer for us. I appreciate it. And primates don't fall into good pets at all then?
Oh gosh, no, never, never, never. Never have primates as pets. All of those videos out there of captive primates being treated as pets, all of those, people on TikTok trying to show off their pet capuchin monkeys. Primates are terrible pets and should never, ever, for the sake of us, and definitely for the sake of them, never be kept as pets.
Thank you to our speakers today. If you would like more information about today's topic or to submit a topic idea, please email info.bna@bruker.com. You can also check out more information in today's show notes. Join us next time as we look at a new solution with more scientists and technicians in all sorts of industries.